The Art of Debugging, a full-stack developer's mindset, a systematic approach to identifying and resolving issues across the entire stack. Debugging is more than just fixing broken code. It's a methodical investigation that requires patience, analytical thinking, and a deep understanding of how systems interact. As full stack developers, we navigate between front end interfaces, backend APIs, databases, and deployment environments, each presenting unique challenges that demand different debugging strategies. The debugging mindset. Before diving into tools and techniques, successful debugging begins with the right mindset. Treat each bug as a puzzle to solve rather than an obstacle to overcome. The best debuggers are curious investigators who ask why at every step, maintaining emotional detachment while staying methodically persistent. Core principles. Assume nothing is working as intended. Question your assumption about how the code should behave. Document your findings as you investigate. Embrace the learning opportunity each book presents. The systematic debugging process. First, reproduce the issue. The foundation of effective debugging is consistent reproduction. If you can reliably recreate the problem, you can't verify your fix. Steps to reproduce effectively. Document the exact steps that trigger the issue. Note the environment conditions, browser, device, network state. Identify the minimal case that demonstrates the problem. Test across different environments to understand the scope. Second, isolate the problem domain. Full stack applications have multiple layers where issues can originate. Your first job is determining which layers contain the bug. Front-end indicators, UI elements not responding or displaying incorrectly. JavaScript console errors, network requests failing to send, state management issues, backend indicators, API endpoints returning unexpected responses, database queries failing or returning wrong data, authentication authorization problems, server-side logic errors, infrastructure indicators, deployment pipeline failures, environment configuration issues, third-party service integration failing. Third, gather evidence. Think like a detective collecting clues. The more information you gather before making changes, the more targeted your fixes will be. Essential evidence sources: browser developer tools, console, networks, elements, server logs and application logs, database query logs, performance monitoring data, error traffic in services reports, user session recording when available. Front-end debugging strategies. Browser developer tools mastery. Modern browsers provide powerful debugging capabilities that many developers underutilize. Network tap investigation. Examine request response headers for authentication issues. Check payload data for malformed requests. Monitor timing to identify performance bottlenecks. Look for failed requests that may be silently handled. State management debugging. Modern front-end applications rely heavily on state management, making state-related bugs common. React debugging approaches. Use React developer tools to inspect components state and props. Add temporary logging to use effect dependencies. Implement custom hooks for debugging state changes. Check for stale closure issues in event handlers. Backend debugging strategies. Structure logging. Effective backend debugging starts with comprehensive logging that tells the story of your application execution. API debugging techniques. Backend APIs are often the source of mysterious front-end issues. Systematic API debugging prevents wild goose chase. Testing API endpoints in isolation. Use tools like Postman, Insomnia, or Cure to test endpoints directly. Verify request response schemas match front-end expectations. Test edge cases and error conditions. Check authentication and authorization flows. Database debugging. Database related issues often manifest as performance problems, or data inconsistencies. Database debugging strategies enable query logging to see exactly what queries are being executed, use database performance monitoring tools, check for N+1 query problems, verify data integrity with manual queries, test with realistic data volume. Cross-stack debugging techniques following the data flow. Many bugs occur at the boundaries between front-end and back-end. Trace data flows end-to-end to identify where transformations go wrong. Data flow debugging checklist. First, verify data format leaving the front end. Second, check data format arriving at the backend. Third, confirm database queries use correct data. Fourth, verify database response match expectations. Fifth, check data transformations on the return journey. Sixth, confirm front-end receives expected data format. API contract debugging. Mismatch expectation between front-end and back-end cause integration bugs. Preventing contract issues. Use API documentation tools like OpenAPI, Swagger. Implement contract testing with tools like Pact. Version your APIs and communicate changes. Use TypeScript interfaces for shared data models. Advanced debugging techniques. Remote debugging. For production issues that don't reproduce locally, remote debugging tools become essential. Remote debugging tools. Browser remote debugging for mobile devices, Node.js remote debugging for server applications, application performance monitoring APM tools, real user monitoring RUM solutions. Performance debugging. Performance issues require different debugging approaches than functional bugs. Performance debugging workflow. First, establish performance baselines. Second, use profiling tools to identify bottlenecks. Third, analyze network waterfalls for front-end performance. Fourth, monitor database query performance. Fifth, check for memory leaks and resource consumption. Security-related debugging. Security bugs require careful handling to avoid creating vulnerabilities. Security debugging considerations. Never log sensitive data like password or tokens. Use security scanners to identify potential vulnerabilities. Test authentication and authorization edge cases. Validate input sanitization and output encoding. Debugging tools and technologies. Essential front-end tools. Browser developer tools, Chrome, Firefox, Safari. React developer tools, Vue.js DevTools, Redux DevTools, Lighthouse for performance auditing, Sentry or similar error tracking. Essential backend tools, application logs and log aggregations, APM tools, database monitoring tools, API testing tools, profiling tools for your specific language or framework, full stack debugging tools, distributed tracing, end-to-end testing frameworks, load testing tools, real user monitoring solutions, building a debugging culture, documentation and knowledge sharing. Create a culture where debugging knowledge is shared and preserved. Documentation strategies, maintain a run book of common issues and solutions, document debugging procedures for complex systems, share post-mortem that include debugging lessons learned, create debugging guides specific to your technology stack. Preventive debugging. The best bugs are the ones that never make it to production. Preventive measures. Comprehensive unit and integration testing. Code review process that catch common issues. Static analysis tools to identify potential problems. Monitoring and alerting to catch issues early. Conclusion. Debugging is both an art and a science that improves with practice and systematic approach. As full stack developers, we have the unique chance and opportunity to understand issues across the entire application stack. By developing strong debugging skills, maintaining the right mindset, and using appropriate tools, we can transform frustrating bug hunts into efficient problem-solving sessions. Remember that every bug is a learning opportunity. The debugging skill you develop today will make you a more effective developer tomorrow, capable of building more robust applications and solving complex problems with confidence. The key to mastering debugging lies not in memorizing every possible solution, but in developing a systematic approach that can be applied to any problem. With patience, curiosity, and the right methodology, even the most elusive bugs will eventually reveal themselves.